Good afternoon and greetings from Chevell College, Oxford. Today's open session is related to A-level studies in maths and further maths. Before I move on to introduce our speaker, I would like to say a few words about the college. Chevell College, Oxford was founded over 50 years ago with an aim to prepare students to enter top Russell Group universities. The college is located in the heart of Oxford city centre, and our study center, is adjacent to the oldest debating society, Oxford Union. You can see on our screen the oldest debating chamber. And this chamber actually represents a miniature of Westminster. Our students become members of Oxford Union, and they use libraries and have a unique opportunity to mingle with undergraduates, visiting debate chamber to listen to prominent speakers or mastering their skills of debating. We are proud to have our purpose-built accommodation, and you can see on your screen that this is a very fairly new purpose-built accommodation students' residence with spacious ensuite rooms and hall where we use and run for seminars and professorial talks. And our next page will be showing some links where if you wish to read more about Chevell College, please use this QR code or visit our website. And now I am delighted to introduce our speaker. And our speaker today is Dr. Thomas Baker, our senior tutor of maths and further maths at Chevell College. And if I'm correct, Tom, and this is the way how we communicate on first name terms. So welcome, Tom.
Hi.
You have been teaching maths and further maths at Chevell since 2018.
Yes, I think so.
Wonderful.
Been quite a while.
Yes, yes. In fact, you have taught many students at Chevell who eventually progressed to Russell Group universities, and some with even unconditional offers, which are quite rare to receive. A few words about your background. You graduated from Oxford and then completed your research at Imperial College London, where you were also teaching. And at that time, you recognized that teaching was what you enjoyed most.
Exactly.
Excellent. And now over to you, and based on your experience, and this is where our agenda, thank you, my colleague has displayed now our session, the structure of our session, and this is where I will pass a floor to Tom to talk about the value of studying maths, and possibly if you can expand based on your experience of teaching A-level students, what would be your advice on how to achieve A and A stars in maths? Thank you.
Great. One of the biggest value of studying maths at A-level is that a lot of universities, or most universities for the different courses and most prospective employers look at maths A-level as a very valuable thing to have. They recognize that if you are able to do mathematics, that shows that you can think about problems and how to solve them in a nice, very rigorous way. And it also shows you have a lot of just general skills for problem solving, whatever topic you do. It is also just useful to be able to build on that for various other areas of study you might be interested in, whether it is for more maths or if it's physics, chemistry. All of these rely heavily on mathematics. So being able to have a really good A-level in it or being confident in mathematics is pretty much vital for half of all university topics. The best way to get a good mark in an A-level in mathematics, I think, it would be to first make sure that you are as happy as possible with the underlying concept, having a really deep understanding of the underlying concepts and how to solve the problems is much more important than say, looking at a question and looking at the answer and saying, okay, this is how I answer this question. I just follow these steps. That doesn't help, because if you're asked a different question, then suddenly you don't know what to do. It's much more important to have a good idea of how you can solve problems in general, using the fact that you have this good understanding of the foundation and the basics. Of course, with mathematics, it also builds a lot on itself. So if you want to build your foundation on top of more foundation. The other thing that is important when trying to get a really good mark is practicing problem solving, practicing using the knowledge that you have learned as much as possible helps you not only to become better at approaching these problems, better at doing problems with good speed so that you're able to answer all questions and under a time condition, and being able to lay out your answers in a good way so that you can get all the marks that you need to get the highest.
Thank you, Tom. And on this point, if I may chip in and ask, what do you think? Over the years, some of international students, when they join, with a difference in approaches to studies, especially when you move from secondary school to advanced A-level, we've noticed that some students really pay too much attention to mark schemes and trying to really use it a lot. And I think you've already partly answered that understanding concepts in math more important than, just following this script with mark schemes. Am I right?
Yes, indeed. With a lot of A-level exams, they will ask questions that you can't just have a set answer to. You need to actually think and problem solve to find the solution. So if you've just looked at a lot of mark schemes and looked at how the answers you haven't learned yourself the skills with which to solve a problem if you're not sure how to do it at the start. You need to build that ability not only with understanding the concepts deeply, but also practicing approaching a new problem so that you are able to answer a question you've never seen before.
Oh, that's a very important to, and I think just some of our students who registered today, they are now in the preparation to sit some exams in May, June. So that's good to know. And another question which I think will help to reiterate and reassure students that when they are working on a problem in their exam paper, they really need to show the way how they solve the problem. And I think this is why one must point out that A-level examiners look at students' work in the margins of an exam paper to understand how they came up to that solution for their assessments. Am I right?
Yes. So an important part of the marks that you get in an A-level is showing the working to make sure that you have understood how to solve the problem. In fact, a lot of the problems involve specifically show that problems where you can't just put an answer and you need to show the working. And this is why I've got these two examples up here of my working answering questions, and I wanted to sort of highlight the importance of laying out your answer as clearly as possible. So if you look at this slide, this is an example which I don't think people should emulate. This is trying to save paper as much as possible by putting two questions next to each other. I would never recommend doing this. Mm-hmm. You should always try and leave yourself as much space as possible and make your argument as clear as possible. So if we go back to the previous slide where I don't add this extra bit, I now have a lot of space where it's and it's very clear that my argument goes down the screen. And if I ever make a mistake, I have plenty of space to make corrections, add in extra notes. It also means that the person who's marking it can sort of see, like writing themselves, what they think of each particular point. It gives them a lot more agency in where to look. With the second slide, there's a lot less space and arguments can get confused and it can be hard to see where exactly one question starts and one question ends. So I would say never do this. Always give yourself as much paper as possible. Make sure just use as much trees as you can. Other people will be able to save the trees once you've got your degree.
Absolutely, that's vital, as you say, and really helping examiners to understand and just bearing in mind that the thousands of papers they have to mark, so it makes sense and helping them to process and understand better.
And also, it goes back to your point of the fact that because the examiners want to give you marks for doing the working, they want to see, oh, you have done this step, therefore I'm going to give you a mark for that. Making sure that your mark working is clear so that the examiners can see that you have done that makes it a lot better, makes it a lot easier for them to find that.
Brilliant. Thank you. Thank you for this advice. Considering that some of our registered participants would like to study A-level maths with a view to applying for maths or combined studies in Oxford or other top Russell Group universities, they are very keen to learn more about the structure of the MAT aptitude test. Can you walk us through this structure?
Right, so the MAT paper it's a quite an interesting structure. The first question is a set of multiple choice questions, which makes up about 40% of the marks. And that's what everyone who does this test will have to do. We'll all have to do question one. And after that, there are further questions which are longer and rely on previous parts of the question more than these ones, which are clearly just all separate. And each applicant has to do a fixed set of questions from the total. That if you're doing mathematics, then you have to choose all the ones that are just for mathematics. If you're doing, say, computer science, then there are some that you don't do and some that you do instead. So if you're just doing mathematics, I believe you do question 1 to 5. If you're doing computer science, you do maybe 1, 2, 3, and 6. I forget exactly the numbers, but the first page lays it out exactly, and you can see at the top it says to all applicants, so everyone does them, and then for other ones it says for just people doing maths or for people doing maths and computer science. So for example, this one's for everyone doing maths and statistics or maths and other things. It's not for people who are just doing computer science though.
It's very useful. Okay, that's wonderful. So, and talking about computer science and philosophy or politics, economics and philosophy, we have a few candidates who registered for this session. This is where my understanding, the next question will be how to prepare for the forthcoming interview. And on this particular note, I would like to mention, just Lewis Carroll or Charles Dodgson in real life, who really talked and certainly, just provoked us to think about math as a creative subject, as he put a lot of riddles and used a lot of philosophical meaning in his book. And this is where, one would certainly, just expect some probably, just tricky questions during an interview. And as we know, Charles Dodgson was teaching math, and this is where, what will be your advice, what to expect, how to prepare, what to read, if you can please help us and help our audience to understand more how to prepare.
So the things that interviewers are looking for in particular when you're asking to do mathematics, is they're looking for people who have a really strong passion for the subject. So you can showcase that by reading basically any mathematics book you like. I have some suggestions, for example, Cabinet of Mathematical Curiosities by Professor Ian Stewart, or Things to Make and Do in the Fourth Dimension by Matt Parker, or The Simpsons and Their Mathematical Secrets by Simon Singh. But it's not hugely important which books you do. It's important that you go out and read books that you find interesting, that you can look at and say, this is really sparking my interest in this topic. I want to go and talk about it more. I want to show that I want to go and study this. A maths degree is a big commitment and it's a lot of work. So they want to make sure that you actually, have the, you will actually sit down and do the work. The other thing that they're going to be interested in the interview is your ability to get a new concept taught to you and apply it. Teachability is a sort of general term. So if you ask me what kind of question would come up, that's impossible to answer because they're always trying to find new questions that you've never kind of seen before. The thing you want to be able to do is react to these new questions or new concepts that you're introduced to, and to be able to understand and then apply them. The best way to practice this is really to do mock interviews. Try getting someone to ask you about a new concept you've never seen before, or ask you questions that you haven't looked at before, and then to talk through them. Another part of that is your ability to sort of solve problems while talking. In the sort of structure of an Oxford interview, they're really wanting you to be able to do an Oxford tutorial, which you'll be in a room with maybe one or two other students, and talking directly to the tutor about mathematics. So you need to be able to say, to speak and think about the mathematics. And so if you're able to do that, that's a very good sign, which practice can certainly help for.
That's very helpful to know, and thank you for elaborating and helping our audience to understand more. And I would like to say that you mentioned about one-to-one, or as we say, Socratic method of learning. And this is exactly the way how we teach students here at Chawel. So as Tom has already mentioned, you are able to run mock interviews, but at the same time, throughout your academic year, you are used to this intensive, to some extent, sometimes, just rigorous, critical thinking. So yes, that's very interesting. And we are living in a very interesting period of time, and this is where everyone talks about AI. And what do you think? What role does math play in the development of AI? And we know that you mentioned already, even in aptitude test preparation, you have just some questions which are focusing for those who are going to read computer science and philosophy. So what do you think, how important math? And if you can just explain your thinking for those who are considering this path.
Well, AI couldn't exist without mathematics. AI, the whole idea of AI is built upon a system of matrix multiplication, which can be very complicated. So having an understanding of what exactly that is doing and how to construct a computer to do these sort of operations is definitely necessary for doing anything involving artificial intelligence. The important part of having mathematics to solve, not only to be able to consider the matrices in the sort of base level area, but being able to see new problems and creatively solve them by thinking outside the box, viewing things in different ways, is just very useful for developing any kind of area, AI or otherwise, because you need to be able to see your problem and find different ways of solving it, or find ways to tell the computer how you need to solve a question.
Absolutely. Now, it's very interesting. And from our side, I would like to add that currently Oxford University and the Faculty of Computer Science, they offer just quite a few open talks, and they are trying to help students, prospective students, to learn more about forthcoming degrees, and the Faculty of Maths is quite active as well. So plenty of resources to be inspired, to be prepared, and as Tom has already mentioned, it's really important to think outside of your box and not to take just maths as a static subject. We have a few more questions, and if I may read those questions. I think one question is related to math as a creative subject. If I may ask you to display so we can read that question. Yeah, very interesting question. Are there any examples in your work where thinking creatively helped you solve a mathematical problem in an unexpected way?
I would say that when doing mathematics past A-level, most of the time you are thinking creatively. As I've been saying, you often need to look at things in a different way. When you're proving things or when you're trying to find solutions, sometimes it's obvious, that's lucky if it is, but often you need to try and restructure the whole problem by looking at it in a new way. There were many examples of this when doing mathematics. Just being able to look at a sum of values in one direction, but then to be able to think of a different way of collecting those values is a trick that's used off so many times throughout different areas of mathematics. Or to be able to take a shape, for example, and be able to consider it as slices in one direction or another, not only useful in the abstract areas of maths, but also very important when you're considering applied versions when you want to do complex integrals. So it's hard to think of one example. There are basically all the time you're trying to think creatively when solving mathematical problems, using your abstract versions of the ideas. But by becoming more abstract, you actually have a lot more creativity because you have a lot more to play with. Mathematics is often about using your axioms, your sort of rules of the game, and saying, well, with these rules, what can I do? How can I build from that?
As you say, mesmerizing and fascinating world. And thank you, Tom, for just giving us very insightful talk, helping our audience to understand nuances of A-level maths and further maths, and certainly MAT preparation. Now I have one more question. What open problems or areas of research do you think are the most exciting right now?
That's a quite a tricky question. There's lots of open problems. You have the famous ones like the Goldbach's conjecture, which I don't think is probably an area you'd want to go into, or the Riemann hypothesis. Very interesting, but quite tricky. The research that I think is quite interesting, one that actually does use AI in a sense, DeepMind uses AI, or Google DeepMind have applied their thoughts to make something called AlphaFold, which is used to predict the folding of proteins, which is incredibly useful for research in all over biology. So it's very useful. But other areas that I think are interesting involve very abstract things. Something past sort of set theory can go to something very, very abstract, or past group theory, which is quite interesting. The ones I'm quite interested in, other areas I'm quite interested in, are something called pseudo-differential operators. There's a way with mathematics of transforming differential equations into multiplying by polynomials. And by playing with that, you can end up with some very interesting ways of solving other differential equations, which happens a lot in physics. You need to solve these differential equations, and that's a gap that can be filled in with these pseudo-differential operators.
Wow, that's a very, it's to my mind, a rocket science. Now we touched a very complex matter, and thank you for that. Thank you for intriguing us and inspiring our audience. That's great. On this note, I think I would like to check if there are any questions, but in the meantime, if I may mention a few pieces of information. So the college, we offer our processional courses in MIT preparation and other aptitude tests in August. So if anyone is interested, please follow our QR code and check. But at the same time, Tom has already alluded and mentioned about innovation and few, just complex problems. And what we have noticed that students at A level really require, just to read around the subject, but also get some access to this innovation ecosystem. And throughout the last few years, we developed a very strong affiliation and global partnership agreement with University of California, Berkeley. And this is where we created and, just added a few elements to our A level. These elements, and you can see this facilitating subjects which we teach throughout our intensive boot camps. And one takes place in Oxford and one in California. And as we've already talked about, math is everywhere. And if you see in, on this screen, we have a slide, modules in innovation. It does contain, just models, business models, but as well, some fundamentals in finance and understanding, the structure of finance. So this is now part of our curriculum. And the industry and faculty fellows are quite experienced. And you can see, just some names, from UC Berkeley, Professor Gigi Van and Dr. Jason Lee, who is teaching in Keble College, Oxford, and some experienced venture capitalists like Peter Henry. So again, just please follow our link if you are keen and interested to learn more. You are very welcome to ask, just any questions, liaise with us. And thank you for joining us today. I think this is our now, just end of the session. We are very grateful to our speaker. And we look forward to our future talks. It's amazing what is happening these days. And, we are very grateful for your time. Thank you ever so much.
Thank you.
Thank you. Thank you, everyone.